All right, if you're an automotive engineer, listen up. This is your strategic briefing for the next 2 years, and it's a big one. We're talking about a fundamental shift, moving away from just ticking boxes for compliance and stepping into a whole new world of AI-enabled dynamic resilience. Let's break down what that really means for the work you do every day.
So, why are we having this conversation right now? Well, look at this number. The systems you're meticulously designing are under attack like never before. Since 2020, we've seen a staggering 380% surge in cyber attacks targeting the auto industry. This isn't some far-off theoretical problem. It's a crisis happening in real time, and it demands a completely new way of thinking.
So here's how we're going to tackle this. We've structured this analysis in 5 key parts. First, we'll talk about the single most important mindset shift you need to make. Then, we'll look at the very real threats that are forcing this change. After that, we'll dive into the new tech you'll be using, navigate the tangled web of global regulations, and finally, we'll land on a concrete engineering playbook you can put into action.
Okay, first things first. If you only take one thing away from this briefing, let it be this. We are at a critical inflection point. The old way of approaching vehicle cybersecurity, the checklists, the static defenses, it's just not going to cut it anymore. It's completely insufficient for the challenges we're facing today.
For years, the entire game has been about regulations like UN R155. And look, getting that type approval is absolutely essential for market access. We all know that. But the industry has had a very rude awakening. Just checking a box on a form does absolutely nothing to stop a determined, sophisticated attacker in the real world.
And this slide, right here, shows the massive paradigm shift we're talking about. The old world was static, it was manual, and its entire focus was just getting the green light from market access. The new paradigm, it's all about continuous, automated defense that protects that vehicle for its entire life cycle. The goal is fundamentally changed from just selling the car to actually securing the car out on the road.
So, let's look at the evidence. What's actually forcing this change? Because the threat landscape hasn't just gotten bigger, it is fundamentally transformed in both its scale and its impact. It's a whole different ballgame now.
And what's really shocking is the severity. In 2023, literally half of all reported cyber incidents had a higher massive impact. We are way past someone hacking the infotainment system to play a different song. We are now talking about attacks that can seize control of critical vehicle systems or paralyze entire commercial fleets.
And these attacks are evolving on every single front. The attack surface, it's not just the car anymore, it's the whole ecosystem. EV chargers, over-the-air updates, the cloud backend. The attackers, they've gone pro. We've moved from individual hobbyist hackers to organized ransomware gangs and even state actors. And the financial stakes, they're astronomical, with downtime losses predicted to soar past $2 billion a year.
So, the big question is, how on earth do we build for this new reality? Well, this strategy of dynamic resilience isn't just a concept. It's enabled by 3 core technological shifts in how we actually engineer and validate vehicle security. These 3 shifts are absolutely fundamental. We're moving from manual spreadsheets to automated living risk models. We're going from generic noisy alerts to contextual detection that actually understands what a vehicle is doing. And we're shifting from superficial black box testing to deep validation that can see inside the code.
Let's quickly look at the tech making this happen. First up, continuous Terra. Think of your risk assessment not as a static report, but as a live dashboard that automatically updates with new threats. Second, AI-powered VSOCs. That's Vehicle Security Operations Centers. They use a digital twin of the car to understand context, which is how they can tell the difference between a simple sensor glitch and a real attack. This is huge for cutting down on false alarms. And third, instrumented fuzzing. This goes way beyond standard testing. It actually injects automated probes deep into the code to find those really complex, hidden bugs that normal methods miss, which, by the way, is now a must for ISO 21434 compliance.
Now, as if the technology and the threats weren't complex enough, you also have to navigate an increasingly fragmented global regulatory landscape. A one-size-fits-all approach to compliance? It's just not going to work anymore.
Just look at how different the major markets are. In the EU, it's all about process audits and supply chain penetration. You jump over to China, and it's a totally different story. They mandate physical testing and have incredibly strict data laws that might force you to build a completely separate system. And then in the US, it's all about supply chain security and geopolitics, with rules about where you can and cannot source your components. You can't use one strategy for all 3. Each one is its own unique engineering puzzle to solve. Okay, so that's the high-level strategic landscape. Now let's bring it all home. Let's move to the final section and translate this into an actionable mandate. This is your engineering playbook for 2024 through 2026.
First things first, you have to have a single source of truth for every single component in your vehicle. That means an automated software bill of materials, an SBOM. Why? Because if you don't know exactly what's in your vehicle, you're flying blind. You have zero chance of tracking vulnerabilities across your supply chain. It's really that simple.
Number 2, shift security left. And that means integrating instrumented fuzzing directly into your CI/CD pipeline. The real game changer here is virtualization. It allows you to run these incredibly deep validation tests long before you have any physical hardware, which will save you an unbelievable amount of time and headaches down the road.
Third, you have to solve alert fatigue. Your SOC team is probably drowning in false alarms. The solution is a vSOC that has a brain that thinks like a car, not an IT server. It has to use vehicle context, speed, location, what gear you're in to tell the difference between a real attack and a false alarm. Your standard IT security tools just can't do this.
Fourth, you have to think about the future today. The threat from quantum computing breaking our current encryption is real. So when you're designing your next-gen ECUs, you must reserve sufficient hardware resources, RAM, flash, HSM performance, so that you can support future over-the-air updates for post-quantum cryptography. You have to design for crypto agility from day one.
And finally, number 5, you have to make security everyone's job. This is not a friendly recommendation, it's a hard requirement. You must write UN R155 and CRA rules directly into your supplier contracts. Define their vulnerability response SLAs. Define what happens at a component's end of support. Security has to be a contractual obligation, not a handshake agreement.
So I'll leave you with a direct question. Think about the project you've got open on your screen right now, the design on your drawing board. Is its security DNA truly built for the threats of 2026? Or is it already a relic of a compliance-driven past? The decisions you make today are going to define the safety and resilience of your vehicles for the next decade.